Make sure you are finishing up any of those missing or late assignments that you have. Again, Chapter 10 is one of the harder chapters, so I do want you to get that practice in. So if you didn't finish yesterday's assignment, please make sure you do that. And today's assignment as well. Okay, there's a lot of formulas between yesterday and today. So today we're going to look at special segments within a circle. So we still are looking at these secants and these tangents within a circle, except now we're going to try and find those segment measures instead of angle measures. So the first thing we have here are segments intersecting inside of a circle. So just like yesterday, we have two secants intersecting inside the circle. Okay, so if two chords or secants intersect in a circle, then the products of the lengths of the chord segments are equal. So products meaning multiplication. So if I look at the picture to the right there, and I have this segment here A, and this segment here B. Okay, they make up that same chord, right? I can multiply A times B, and it's going to equal C, this first segment here, times D. Okay, so within that same segment, I can multiply the two together, set it equal to the other two that make up that segment together as well. Okay, so we're going to do an example of that one. In A and B here, we want to solve for the value of x. Okay, so x is this piece right here. Okay, the other segment that makes up that entire chord is this segment of 10. So I can multiply those two segments together. So we have 10 times x. Now that's going to be equal to, if I look at the other chord within my circle, again I have two segments that are created. I can multiply those two segments together as well. So I have this segment AB, which is 5, times this segment BC, which is 12. Okay, so I have 5 times 12. So I end up with 10x is equal to 60. Just divide by 10. And that x value will be 6. So that segment EB is then 6. Okay. Questions on letter A before I do letter B? All right, so in letter B, I still want to solve for x. Now, this time I have my x's in two separate segments here. I have this length is 2, and this radius is 10. So before I start multiplying, I do need to find out what this section right here would be. Okay, because I'm missing that section for that entire segment. Well, if I know my radius is 10, that means this entire radius has to be 10, and I need to subtract 2 out of that to get this remaining section, which is 8. Okay, so the entire segment right here then would have to be 18. Okay, you need that entire section in order to multiply it by 2. Okay, so now I can take these pieces of my first chord, has my x's here, so I'll take x times x. Okay, that's equal to my second chord. The first piece is 2 times that second piece of that chord is 18. Now if I have x times x, what do I have? X squared, good. 2 times 18 is 36. Okay, then we just need to take the square root of both sides. And again, when I take the square root of both sides, I do end up with this plus and minus. But since I'm looking at a segment length, I don't need that negative value answer. So I can just say x is equal to 6. Okay, so all we're using is this formula here. Okay, take your first chord, the different pieces from it, multiply them together. Second chord, take those pieces from it, multiply those together, and set them equal. Okay, questions before we go into another example? All right, so in our next example here, it says the true shape of a rainbow is a complete circle. However, we see only the arc of the circle that appears above the Earth's horizon. What is the radius of the circle containing the arc of the rainbow shown? Okay, so we want to figure out what the radius of the entire circle is. Now, here's our picture. We have our rainbow. We know this distance from the ground to the top of the rainbow is 0.7 miles. And we know across is 5 miles. So if I complete that circle, that's what's drawn over here, you can see this rainbow shape. We have that 0.7, and across the whole thing is 5 miles. Now since AC right here, okay, AC is a chord of that circle. And DB, okay, is a perpendicular bisector. Of AC. So since it's a perpendicular bisector, do you remember from section 10.3 when we had a chord and then we had the diameter or radius as a perpendicular bisector? It split that chord into 2 equal parts. That's why both of these are 2.5. Okay, so we took 5 miles, split it equally between the two. So now we kind of have a circle that looks like our examples from above. So what I'm going to do first is figure out what the diameter of my circle is. Okay, so I'm going to figure out what this length from B to E is so that I can figure out that diameter so that I can figure out the radius. Okay, so from here we're just going to take our pieces of that first chord. We can multiply them together just like we did above. So 2.5 times 2.5, okay, from the same chord. That's equal to the other pieces from our other chord multiplied together. So 0.7 times x. Okay, from here I'm just going to solve for x. So if I multiply 2.5 times 2.5, I get 6.25 equals 0.7 x. Divide both sides by 0.7. Okay, and that x value then is 8.9. Now, in our problem, we were looking for the radius. Okay, so we need the radius of this circle. Right now, I have that D to B is 0.7 and B to E is 8.9. So I'm able to find the diameter of this circle by adding together those two pieces of that chord. So 0.7 and the x value I just found is 8.9. Okay, so the diameter then is going to be 9.6. So then how could I find the radius of the circle if I have the diameter? Divide it by 2. So to find the radius, we'll take 9.6 and divide it by 2. So the radius of that circle is going to be 4.8 miles. And you do have a problem like this on your homework. So again, first thing I did was just complete this circle. Okay, I found this missing piece from that diameter using the formula up here above, okay, where I can multiply each of those pieces of those chords. Then I found the diameter by adding them together and dividing by 2 to get the radius. Okay, questions on that first example? All right, then example 2 says the highest point or apex of the Astrodome is 208 feet high and the diameter of the circle containing the arc is 710 feet. We want to figure out how long the stadium is from one side to the other. So it's very similar to our rainbow problem above. Okay, so we have a circle. Okay, the dome is going to be just like a piece of that circle. It's not drawn across like the diameter. It's just that upper piece. Okay, but I am given the length of the diameter, so I do want to draw that in. All right, so in our problem, we have this Astrodome is 208 feet high. Okay, so that 208 is going to be from our first chord drawn in to the top of that circle. Okay, so that's 208 feet there. Now we're also given the whole length of the diameter. So how can I find this piece of my chord drawn in? Subtract. So I would take 710 minus 208, okay, to get this length right here, which is 502 feet. Now, in my problem, I want to find out how long the stadium is from one side to the other, okay, but I want to use my formula that we just talked about above. So since this is a diameter intersecting a chord, it's going to be perpendicular, okay? That means it splits that chord into 2 equal parts, okay? So these 2 pieces are going to be equal. So if I label one piece as X, that means the other one also has to be X. So now I've set up this problem where I can use that formula from above, A times B equals C times D. So I can take those 2 pieces of those chords and multiply them together. So I'll multiply X times X, because that's my first chord. And then I'll set that equal to 208 times 502. So the 2 pieces from your second chord. And from here I can solve for X. So again, if I have X times X, that is X squared. Okay, that will be equal to 104,416. Then take the square root of both sides. And again, you end up with a plus and minus, but you don't need that negative value because we're talking about the length of a segment. Okay, so our X value will be positive, and it's 323.13 feet. So that's just half of that section, right? In my problem, I want to find out how long the stadium is from one side to the other. Okay, so our X value is just half of that. So to find the entire distance, we need to add both of those together, or you could multiply by 2. Doesn't matter. Okay, so I need to add both of those X values together to get the entire length. Is 646.26 feet. Okay, questions on how I did example 2? Creating the circle. You want to draw in that diameter since that's what you're given. Draw in your chord. Okay. And again, you're just using that formula from above, taking each piece of that chord from that intersection, multiply, set it equal to the other two pieces from the other chord. Okay, then if we go to the back, you have an intersection outside your circle. Okay, so just like yesterday, we started with an intersection inside of our circle. Okay, now we're going to look at an intersection in the exterior of a circle. Okay, and this is with two secants. Okay, you have something different when you have a tangent and a secant. Okay, so with two secants on the exterior of a circle. That formula, okay, is going to be the exterior segment times the whole segment is equal to the other exterior segment times that whole segment. Okay, so if I look at the picture on the right here, that would be my exterior segment from my first secant is AB. So I would take the length of AB, multiply it by the entire secant segment there. Okay, so that would be AC. Then that is equal to, if I look at the other secant drawn in, that exterior segment is AD multiplied by its entire segment, which is A to E. Okay, so we're going to use that formula to do numbers 1 and 2. So number 1, we do have an intersection outside of our circle, and we do have two secants. Okay, so first I need the exterior segment. So in this one, that would be JH. That's 8. Okay, then I need to multiply it by its entire segment. Okay, so I need this entire segment here. Now there's an X within that one. So to get the entire segment, it's not 8X, right? We have to add those two together. So this would be X plus 8. Okay, so that entire segment is X plus 8. Okay, that's equal to the other exterior segment is KJ, and that's 6. That's multiplied by the entire segment of LJ, which is 16. Okay, so I had to add 10 and 6 together to get that entire segment of 16. Okay, so from here, now I can solve for x. First thing that I need to do is distribute this 8 to both terms inside those parentheses. So I have 8x plus 64 is equal to 6 times 16, which is 96. Subtract 64 from both sides. To get 8x is equal to 32. Then divide both sides by 8. X is equal to 4. Okay, so again, it's the exterior segment times its entire segment is equal to the other exterior segment times that entire segment. So you do have to add those two pieces together if you're not given that entire segment length. Okay, questions on number 1. All right, then I want you guys to set up number 2. Don't solve it, just set it up, okay? So set up number 2. Don't solve it though. I'll show you how to solve it. Yeah. You can solve it. You have to factor. You could solve it. You learned how to factor last year. Do you have a question, Garrett? Oh, okay. Okay. All right, so this is how you should have number 2 set up. So I have my exterior segment is x times my entire segment. I would have to add those two pieces together to get x plus 9. That's equal to the other exterior segment is 4 times the entire segment is 9. Okay, so from here, again, first thing I want to do is distribute this x to both terms. So I have x times x, that's x squared, plus x times 9 is 9x. That's equal to 4 times 9 is 36. Now, if you have an x squared and an x within your problem, this is a quadratic and you do need to factor it. So I need everything on one side of that equation. Well, if you don't like this, you're going to hate the next problem. So I'm going to subtract 36 from both sides. Okay, so that gives me x squared plus 9x minus 36 is equal to 0. Now what I want to do is see what multiplies to negative 36 but adds to 9. So if you need to, write out your x. What multiplies to negative 36 but adds to positive 9? 2 numbers multiply to negative 36 and adds to 9. Well, it's not 9 and 4. It's not 6 and 6. 12 and 3. Okay, so you would have 12 and negative 3. Okay, so if I multiply those two together, I get negative 36. If I add them together, I get positive 9. So back over at my problem here, this factors into x plus 12, okay, because that was positive, times x minus 3, because that was negative. That's still equal to 0. So now what I can do is set both of those quantities equal to 0. So I have x plus 12 is equal to 0, and x minus 3 is equal to 0. And I just have to solve both of those. So subtract 12 from both sides. I get negative 12. And I would get x is equal to 3 here. Now, since we're talking about a length of a segment, this segment length cannot be negative 12. So that is not one of your answers. So your answer must be x is equal to 3. Okay, questions on number 2 on the back here? All right, last section. This one has to do with a tangent and a secant. Okay, and it is on the outside of a circle. Okay, so tangent and a secant on the outside. So I have two different formulas for when they intersect on the outside. You have this one up here. That's 2 secants. Now this one has a tangent. Okay, so you do need to identify which one it is. So make sure you're looking out for those tangent segments. So you will have this point of tangency K right here. So the formula for this one, I still have this exterior times the entire segment for the secant. Okay, so I still have this JL piece times JM. Okay, so with the secant, it's always the same. However, that's going to be equal to this JK piece squared. Okay, so that tangent piece, you're going to square it. And then set it equal to the exterior segment times the entire segment. I don't know. Off the top of my head, why would I know that? A couple? There's not 6 of them. At most, I think there's 3. All right, so we're going to go over an example of this. So PQ is tangent to the circle. We want to find x, and we need to round to the nearest tenth. Okay, so here, since we have this tangency piece, I'm going to take PQ and square it, because I have to square that tangent piece. So I'll end up with 8 squared. That's equal to, since this is a secant, you need the exterior piece, which is x, times the entire segment, SQ. And since that has an x in it, we need to have x plus 7 for that entire segment. Okay, so from here I'm just going to simplify a little bit. 8 squared is 64. Here I have to distribute that x value to both terms. So I end up with x squared plus 7x. Again, this is a quadratic. I have an x squared and an x value. That means I need everything on one side of the equation. So I'm going to subtract 64 from both sides. So I have x squared plus 7x minus 64. You cannot factor this. Okay, do you remember what you have to use if you can't factor a quadratic? You have to use the quadratic formula. Okay, so the quadratic formula, you need to have your quadratic in this form here. Now that form is considered a times x squared plus bx plus c is equal to 0. Okay, so that's how we have our form here. So this a value in ours is just going to be 1 because there's not a number out there. B will be 7 and c is negative 64. Now your quadratic formula is x is equal to the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Do you remember the quadratic formula? You had to use it last year. Learned about it last year. So the reason I wrote this piece down is so you know where A, B, and C are in your formula, okay, in your quadratic. So to find my x value, all I need to do is plug in each of those values. So for my equation, I need the opposite of B. B is 7. So I need to take the opposite of 7, plus or minus square root. Again, b is 7, so 7 squared minus 4 times our a value. Okay, a is in front of x squared. If we don't have a number there, it's just 1. Times the c value. C is that constant on the end, so ours is negative 64. Okay, that's all over 2 times, again, our a value, the one in front of x squared, that is 1. Okay, so from here, I'm just going to simplify everything inside my radical. So I have negative 7 plus or minus square root. 7 squared is 49. Okay, I have this minus 4 times negative 64. Okay, so you need to take negative 4 times negative 64. So you should get a positive 256. Okay, and that's going to be over 2. Okay, so just add your two numbers here inside your radical together. That's 305. Now that plus and minus means you get 2 answers, just like we got 2 answers when we factored. Okay, so with a quadratic, you should always get 2 answers. So that means I need to take negative 7 plus the square root of 305 all over 2, and negative 7 minus the square root of 305 over 2. Okay, so you have to use that plus and that minus. You can just plug that into your calculator and then round to the nearest tenth. So for this one on the left, when I add the square root, I get a positive 5.2. For this one on the right, when I subtract that square root, I get a negative 12.2. Okay, and again, since I'm talking about the length of a segment, you don't want that negative piece as your final answer. So our x value will be 5.2. Now, for any quadratic, you can use the quadratic formula even if it is factorable. Okay, so for the one that we did in number 2, if you'd rather just use the quadratic formula, plug in those numbers to get your answer, you can do that. You'll get the same answer. Okay, so if you don't want to factor, you don't have to. You can always just use the quadratic formula to get your answer. Okay. Any questions?